I wanted to talk about something different today, which is related to functional programming, but from a very different direction. So for fun, I like playing computer games. And I found this computer game, it's this kind of simulation game called Factorio. And I started playing it. And I really enjoyed playing it. I kind of got, almost addicted to it. And I thought, what's wrong with me? Well, what happened is that it has the engineering part in it. And I'm sort of part engineer and part, doing science. And I found that there are some elements of Factorio that remind me so much of functional programming. It's like I am actually writing programs, I'm building factories and I feel like I'm writing programs. And not only that, but I'm writing programs using a functional language, which was kind of surprising, right? So let me explain to you like what I mean by that. So functional programming starts with functions, obviously, right? So you have to have functions. What's a function? A function takes an argument and produces a result. Now in Factorio, that corresponds to an assembler. An assembler is this sort of assembling machine, little factory that produces stuff, but it needs input, right? So here's an example of a little assembler that produces copper wire. Okay, so if you click on it, you see that there's a recipe. So the recipe really is the function here. Okay, and it looks like a function that takes one copper plate and produces 2 coils of copper wire. So it's really like a function in a strongly typed system. So Factorio is not really strongly typed, but parts of it are really strongly typed. So I could immediately translate this recipe to Haskell or to other languages as well, but I use Haskell. So this will be make copper wire, takes a copper plate and produces a pair of copper wires, okay? A pair is a product type. So are there more examples of this? Well, there is another assembler that produces iron gear, okay? Now this one takes a pair of iron plates and produces an iron gear. And there are other assemblers that take tuples that have differently typed arguments. So you can have an assembler that produces red science. These are called science packs, right? And it takes a pair, the first component of which is copper plate and the second component is gear. So we have, not only we have types and functions, but we also have things to combine types, which are product types. Now in Factorio, they put a plus sign because like in a common language, you say this and this. It's a plus, but really it's an and corresponds to a product type, which means that you have to have both ingredients in order to make something, right? Now the next thing that you do when programming is you combine functions, right? So suppose that you have at your disposal copper plate and iron plate. These are like basic ingredients, right? And you want to produce, let's say, a green circuit. So the recipe for green circuit is you need 3 copper wires and an iron plate, and that gives you a green circuit. but you don't have copper wire. So you have to produce copper wire using the assembler that takes a copper plate and produces copper wire. The combination of these two, so in two assemblers, connect them together, output of one becomes the input of the other, right? That's what we call a function composition. So in a programming language, we would say we are creating a new function by composing these two functions. We cannot express this in Factorio. It's like we would have to say, well, we need an assembler that takes two assemblers and produces a third assembler. That would be higher order programming. So we'll talk a little bit later about higher order programs, right? I couldn't come up with simpler examples of composition because in Factorio most recipes take multiple arguments. So now we have types and we have functions. So that reminds me of category theory, right? Types are objects, functions are morphisms, right? We can compose them. The composition is associative, you know, it doesn't matter, like if you compose three assemblers together, one after another, it doesn't mean that you first composed the first two and then added the third one and so on. So there is one more thing in category theory. To make it a categories, you need an identity function, identity morphism, which means you need something that does nothing. Okay, and in fact, in Factorio, you have something like that. It's called an inserter. An inserter takes an argument and does nothing to it. It just moves it from one place to another. So it's a do-nothing function. So we have a category here, since we can produce pairs, you know, we have product. So this is called a Cartesian category. Right? So, well, we already have a Cartesian category. Now, if you want to do functional programming, obviously you need higher order functions. Higher order functions are the basis of functional programming, right? So, what would that be expressed in Factorio? Not that you can actually do this in Factorio, but you can illustrate this stuff. So, do we have higher order functions? We have a function that produces assemblers. Okay, there is a recipe that takes a green circuit, an iron gear, an iron plate, and produces an assembler. Now this is it's not a very strongly typed assembler. This is this sort of generic assembler, and there is like an additional input that's necessary, that's provided by the player to select, we would say, from an enumeration of all possible assemblers. So you select a particular type of assembler and make it a strongly typed assembler, right? So you get a weakly typed one and you make it a strongly typed by selecting what it's supposed to do. So, strictly speaking, we should think of the recipes as functions and assemblers themselves as objects or types of functions. There's a subtle distinction when you can actually, which allows you to do functional programming. It allows you to pass functions as arguments and return functions as results from other functions. It means that a function has to be objectified. And the objectification of a function in Factorio would mean that a recipe is a function, an assembler that uses this recipe is its objectification. So you can create an assembler or you can take assembler as an argument. And in fact, there is a function, there is a recipe that takes an assembler and produces assembler. These are like two different kinds of assemblers, first type and second type of assemblers. But you have higher order recipes, okay? So there is one thing that I'm kind of hiding, shoving under the rug, and that's in functional programming, there's no mutation, right? You never change anything. And in Factorio, you have these assemblers that take arguments and they consume them. Okay, so arguments are actually resources in Factorio. And this is a problem with which a lot of programming languages have to deal with. And there are mechanisms for this. And in C++, you have things like unique pointers and move semantics. Then you have Rust that is very heavily involved in resource management, right? Because it has these ownership types. And in Haskell recently, we have things called linear types. A linear function is a function that actually consumes its argument. So once you call this function, the argument is no longer available. And this is perfect. This is perfect for Factorio, right? I mean, in Factorio, all the assemblers are actually linear functions. They consume the resources. And in fact, like when you build your whole base in Factorio, it's one gigantic linear functions that consumes, let's say, iron ore, oil, water, whatever, produces something else, like a rocket, spaceship. Right? So the next thing that we have in functional programming is currying. Okay, it's like Haskell is just like, this is the basis of Haskell, currying. Everybody is curried in Haskell. What does it mean? And I'm going to illustrate it again using assemblers in Factorio. So first of all, the idea of partial application of a function. So suppose you have an assembler that takes copper plate and iron gear and produces red science, right? What happens when we give it a copper plate? Well, that's called partial application, right? It still needs an iron gear. So this assembler, after consuming the copper plate, becomes conceptually a new assembler that requires one argument, namely the iron gear. So we have a way of taking an assembler, partially applying it, and producing a new assembler that's a one argument assembler, right? So we start with a two argument function and turn it into a one argument function by providing the first argument, right? So this is called currying, and let's just write it for our assembler recipe. So we have make gear to red science. That's something that takes a copper plate and produces this primed assembler that only requires a gear. So I'm replacing the assembler here with its recipe. So assembler that takes a gear and produces red science is just in parentheses gear arrow red science. That's the new assembler, right? How would we implement this? Well, if you want to return a function, you have to use a lambda, right? So we would say make gear to red science, takes a copper plate and produces a lambda that requires a gear. And what does it do with this gear? It passes it to make red science assembler. together with the copper that has already obtained before, right? So it's interesting is this lambda that you are returning already has the copper in it, right? So this is called what we call a closure in programming. A closure is sort of partially primed assembler that already has one of the ingredients. It captured the ingredient from the environment. It already has it, and now it's expecting on the second one. So we are returning a closure. Now we can automate this process, and we can say, give me this two-argument assembler, two-component assembler, and I will give you an assembler that takes the first component, the copper plate, and gives you an assembler that needs an iron gear. Okay? So this is called Curry red science assembler. Right? Takes one assembler, produces another assembler. The first assembler, I'm writing this assembler as a recipe. So this has a recipe that takes a pair and produces red science, right? And it produces another assembler that takes copper plate and produces this partially primed assembler that needs a gear to produce red science. Follow this? This is like the important part. You get one assembler. It produces another assembler that takes an argument and produces an assembler. Okay, but you can, like, with assemblers, you can imagine, like, okay, this is a primed assembler. This already has a copper plate in it, and so on. And in Haskell, we would implement this as a lambda function that returns a lambda function, right? And of course, this will work for any types, not only copper gear. It will work for ABC. I can replace these things with ABC, and I get a function called curry. It takes a function of two arguments and produces a function that takes one argument and produces a function. Okay? There's a little bit of juggling here, but that's what currying is. So far, we've been not talking about how the items are delivered to functions or to assemblers. We can simply drop them individually, but that's kind of boring. I mean, Factorio is all about automating things. So we want to be delivering things in bulk. Okay, that means we need all kinds of containers there. And there are chests, there are train wagons, barrels, and there are conveyor belts. We'll talk about conveyor belts because these are interesting. So in programming, we would call these things functors. So let's say we have a conveyor belt of copper plates, right? And we want to generate a conveyor belt of copper wire, right? Well, that's very simple in Factorio. You just take one conveyor belt and put the assembler in between, and you just feed the copper to the assembler, and you get a copper wire, right? But this is, from the point of view of functional programming, what we are doing is we are applying a function to a functor full of items, right? Anything that can support this kind of activity is called a functor. So that's the defining thing of a functor, that you can apply it to the contents of a container. Right? So how would we write it in Haskell? Well, we would say data belt of A, where A can stand for any thing. So it could stand for copper wire, iron gears, and so on, right? So in particular, we can say belt of copper plate, right? In Haskell, we could model it, for instance, with lists. So we would have a list of copper, right? And then this operation of applying a function to a functor is usually called map, or fmap sometimes. So map belt would be something that takes a function that turns a's into b's, right? And produces a function that takes belt of a to a belt of b. And this is what we did. So when we say make belt of wire, you know, we take a belt of copper plate and produce a belt of pairs of copper wire, right? And it's simply implemented as using map belt and giving it a function. So this is partial application of map belt to a function make copper wire, and still expects a belt of copper plate, right? And it will produce belt of pairs. You can also think of this as an infinite stream. You can model it as an infinite stream in Haskell, right? And this works for any kind of a container that is functorial, right? I mean, not all containers are functors in principle, but there is a general, we could write a general function map that takes a function from A to B and takes the f of A, which is a functor full of A, and turns into a functor full of B. Okay, now we have, we talked about product types, right? Like coupling things together into tuples, into pairs, and so on, or bigger tuples. You know, that's considered a product type. But interestingly enough, there is a sum type also in Factorio, and it's, the example of this is interesting. This is the processing of uranium ore. So uranium ore is processed in a centrifuge, and the centrifuge takes uranium ore and produces a sum type, because it can randomly produce either uranium-235 or uranium-238. In most cases, like 99.3% of cases, it produces uranium-238, but occasionally it will just drop a little piece of uranium-235, 0.7% of the time, okay? So the result type of this kind of function, or this kind of centrifuge, is a sum type. I mean, in Haskell, we would write it as an either. So you give me, make uranium, takes uranium ore, and produces either U-235 or U-238. In other languages, it's also called a tagged union. And if you have a centrifuge that produces a sum type, it means that it will occasionally produce one and occasionally another one. So you have to be prepared for both, which means you need two functions, a pair of functions to process the output of something that produces a sum type. So to process a sum type, you need a product of functions. You need a pair of functions, right? And often this is done in Factorio, it's done using these filter inserters. So a filter inserter is something that takes a sum type, right, and produces just one of its components. So we would say filter inserter U-235 is something that takes an either of U-235 or U-238 and produces a maybe of U-235. Because if it's given U-238, it will produce nothing, right? So it has to use this optional type or maybe type, right? So you can also think of, you know, like when you have a mixed belt, because belts are not really strongly typed. these are sort of functors that accept multiple things at once. But you can model this as a functor that accepts a sum type, right? So you can have a belt full of things that are either iron gear or iron ore, or whatever. So these sum types are useful in that case. But now there's this interesting thing that conveyor belts can actually, they are two-sided, so there's a left and right side on a conveyor belt. So you can actually use it to transport pairs of elements. And these could be pairs of different types, right? So for instance, when we have red science assembler, right? Make red science. It takes a pair of copper plate and gear and produces red science. So if we could give it a conveyor belt that contains pairs of copper plate and gear, copper plate on one side, gear on the other side, then we could map our red science maker over such a belt of pairs, right? So a belt is a functor, so we can map the stuff, and this functor contains pairs, so we can map a functor that takes, we can map an assembler that takes pairs, right? But how do we produce a belt of pairs? Well, we have to be able to merge two belts, okay? So there is a merge operation, and this is just implemented by just like, weaving these belts. So one belt goes to the right, one belt goes to the left, and they combine. So you combine two belts and produce another belt. And this merging, okay, we would say, okay, a merge belt function, right? Which is implemented in Factorio as this kind of combination of belts. It takes a pair of belts and produces a belt of pairs. Okay, pair of belts into belt of pairs. I mean, in Haskell, we would implement this as zipping two lists. But this kind of operation of merging is not every functor supports this operation. In fact, in Factorio, I think only belt supports this operation. So belt is a special kind of functor, which is called a monoidal functor, right? Because monoidal multiplications, it's like taking pairs in this case. So a monoidal functor is a functor that has this merge operation. And in general, we would write it as, take pairs of FA, FB and produce F of pairs, where F stands for belt or something else, maybe, and A and B stands for different items, different types of items, right? And actually, like if you want to implement a monoidal functor, there is one more functionality that you have to have. You have to be able to produce a functor full of nothing, sort of like ask yourself the question, like if we are merging two belts, what kind of belt do I have to have so that, like, if one of the inputs is copper belt, the output should also be copper belt, right? A belt of copper plates. So what is the do-nothing belt? And the do-nothing belt is just an empty belt. So this ability to produce an empty belt, which is sort of taken for granted in Factorio, right? It's harder to produce a non-empty belt. But then the ability to produce an empty belt is part of this monoidal functor structure. So an empty belt, when you merge it with a belt of copper, you will get a belt of copper. So there's a lot of other things that you can implement. You can figure out, how would I implement this in Factorio, right? I mean, you can think of applicative functors, for instance, which are sort of based on monoidal functors. And then you could think of monads. So what would a monad be like in Factorio? So for that, you would need to be able to have containers of containers, okay? And to some extent, you can have a conveyor belt of conveyor belts in Factorio. What you cannot have, unfortunately, is, and maybe this is like a real life thing, you cannot have a conveyor belt of conveyor belts that are filled with copper, let's say. So, but if you could, okay, if you could, then in order to have monad functionality, you would have to be able to flatten a conveyor belt of conveyor belts of copper, sort of unload it and reload it into a single conveyor belt. So just squish 2 layers of conveyor belt into a single layer of conveyor belt. So unload the copper and put it on a single conveyor belt. That would be a monadic. In Haskell, it's called join, right? But using join, you can implement bind and so on. So there are like other things, completely different areas. For instance, you have trains in Factorio. And if you have trains, it means you have concurrency, because you can have multiple trains coming to the same station or crossing through the same crossing, and they would conflict. So like if you have a data race in Factorio, that will be called a train crash, right? And would be very unpleasant. Of course, in order to avoid data races, you need mutexes or locks, right? So in Factorio, you have train signals. And then once you have logs, and of course, you will have deadlocks. And sure, you have deadlocks between trains in Factorio as well. If you're not very careful and you don't test your railway system, you will have deadlocks. So you might ask yourself a question, but in Haskell you have software transactional memory, for example. What would it mean to have STM in Factorio? Well, you would have sort of like multiple trains coming to the same station, and the train would try to cross. Forget about all other trains. Let me just go through the station, right? Transactionally. So I'm starting a transaction, going through the station, right? And then at the end of the transaction, I check, has any other train crossed the station while I was doing my transaction? Because if they did, I would collide with them, right? And so if they didn't, then I commit transaction and I'm fine. If somebody else crossed the station and committed a transaction in the meanwhile, well, then I say tough luck and restart the crossing, and so on. So I think this is really fun from the point of view that there are all these extremely abstract ideas related to functional programming and category theory, and they can be illustrated in something that's so hands-on, so engineering, and it's like this connection between engineering and essentially category theory. This is a very fascinating thing. Like category theory you can find everywhere, even in building factories, and I think this is a very interesting thing. So I will end with that, and thank you very much.
Other questions? Peter, go ahead.
Thank you. Can you hear me?
Yes.
Yes.
Yeah. So very fun presentation, Bartosz. Really liked it. Never heard of Factorio, so I'm going to have a look at it. I was thinking though, I would assume that you can build things in Factorio that you couldn't do in Haskell. So I wonder how far the analogy goes. So I would assume that Haskell demands you to be a more disciplined programmer than the things you can build in Factorio. Is that correct?
Well, I was thinking that, I mean, there are parts of Factorio that are very weakly typed, right? Like the containers can contain anything. Well, you could, in principle, you could treat them as containing some types, because you can have either this or that or that or that or that. Yeah, and then the thing is that in practice, when you are playing Factorio, you usually you try to be typed. You know, it's like you really don't want to mix, like when you mix like stone bricks with steel, you know, on a belt, your whole factory grinds to a halt. So this is like an example of like, no, dynamic typing doesn't really give you much, you know?
Yeah, so the thing I was thinking of, so for instance, can you create in Factorio strange loops in these belts?
You can have a looping belt. Yeah, the belt can loop on itself. Yeah, this is sort of like a sushi belt, it's called, that goes around. Yeah.
Yeah. I don't want to steal any questions.
Okay.
Okay. Walter, go ahead.
Hi. So I'm wondering how long before we all sit on the couch with a controller and program.
Yeah.
Yeah, because I think it would be pretty nice. Like, there's only so many constructs you really need, and it's just about naming these functions. That's kind of the part that's not fun to do on a controller.
Actually, it's a computer game. It's I mean it's available both on a PC and on Apple. Mac.
Yeah.
So
yes.
You have the keyboard. You can actually, yeah.
Yes, but it would be more convenient to just sit with a controller, right? So to take it up another level. And then, you would need to name these functions, but that's not convenient. But Excel has this nifty trick where it names all your functions for you by just having cells. So that might be one way. But it would be nice to have this Factorio interface rather than an Excel spreadsheet.
I think the interesting question would be, like, what are the things in Factorio that one could easily add to make it more a functional programming language? And what are the things in real life that prevent you from doing this? Like, I was thinking of this, like, can you implement a monad? You know, you would need a conveyor belt carrying iron or copper, you know. It's like, that does not make sense in real life, right? So there are certain things that, it's like, because in programming, you can have things inside things, right? And you can put a bigger thing into a smaller thing.
Well, where does the
conveyor? When I
go?
say this, you know, I immediately think about, in Factorio, you can actually grab a tank and put it in your pocket. So a bigger thing in a, supposedly, like, the pockets are small. I don't know. Maybe the Factorio player is a giant that has gigantic pockets that can put a tank inside. But yeah.
Or where does the conveyor belts get produced?
They're produced in assemblers. Yes.
Okay, on a conveyor belt.
So if you could put an assembler on a conveyor belt, yeah, that would be interesting. Yeah.
Cool. I'll hand over now.
Other questions we go. Yusuf, go ahead.
Yeah, hi there. So I was wondering if you or anyone else maybe had some experience with similar kind of games that could be used to think about functional programming concepts, especially for students. One of them that I've run across is a game called I think it's Opus Magnum by Zachtronics. It's like another little puzzle game. Again, you put things together, and they're like functions, and you have resources, and you pull one thing from here to here, conveyor belts, and all of that kind of jazz there. But one of the things that stopped me from kind of using these as sort of teaching or classroom examples is that they are physically limited in the sense that the track goes this way and this way, and you can't cross the two of them, and you can't. Whereas in a computer, of course, that physical spatial limitation goes away. So if one starts off thinking in the concrete sense of tracks and belts and assemblies over here, and then one also gets into the habit of thinking that, well, how do I get resources from here to there, which is something that computers make literally zero cost, and games don't. And I don't know if you've thought of that aspect or played another game that maybe addresses it.
Okay, so there is one thing in Factorio that could be used for that purpose, and that's drones. You can actually, you have these flying drones, so they can move stuff between assemblers and crisscross their paths in an arbitrary way. So you don't have this problem of two-dimensional weaving, because they have the third dimension. I mean, it's a two-dimensional game, but they can fly.
That's a good solution. Those would be the little unexplained white things that kept on going to your guy.
Yes.
Okay.
Drones. Yeah.
All right, fantastic. I'll give it a try. Thanks.
Let's see. Well, while we wait for another question, I do have a question. So for your first question, you said that you were not sure if it was Turing complete because you were not sure if you had recursion. But if you have functions, then you have recursion, right? Because you can write a fixed point, and the recursive function is just the function that's being called recursively. It's just an argument to the function.
Say it again.
So once you have functions, you have recursion, because the function.
Once you have higher order functions. Yeah.
Yes. Because once you one of the arguments is the function that you would call recursively. So instead of calling the function, you just call the argument that is given to you to make the recursive call. Right. So it's a kind of a fixed point.
Except that it's like, okay, but can you build an assembler that would accept assembler and actually use it? You see, thing is that though it doesn't use the assembler the way you're supposed to use a function object. You're supposed to use the function object by just calling it, providing an argument and getting a result, right? But it just destroys it and produces some other thing, some other assembler instead of calling it. So there is no evaluate function that an assembler could call. Yeah. So, but that's, I mean, maybe one could extend Factorio to do that. I don't know.
My question is, what is the difference between a linear function and the usual pure function? Or what does it mean that an argument gets consumed?
Do you program in any of the Rust or C++?
I have some basics in Haskell, and yeah.
Okay, because what does it mean? This is something that the compiler can check. right? If you declare a function as linear, then the compiler will check that the argument to this function is used once and only once. So after it's used, right, for instance, passed to another function, you cannot access it anymore. It's gone, right? It's like deallocated. You cannot access it.
Okay.
So there is, I mean, I don't know if it's already available in the latest release of Haskell, that is the support for linear functions, and they've been working on this for quite a long time. And it's so every language needs some kind of linearity to deal with resources, right? I mean, you allocate memory and you forget to free it. You allocate memory, you deallocate memory, and you still try to access it. You get a fault, right? So this is a problem that every language is struggling with.
So it's a low-level thing, not a high-level design thing. Yeah. Okay. Thank you.
Okay. Bartek, go ahead.
Hello. Two questions about playing. Did you try some mods for Factorio, like the assembler that decompose the thing to the simpler one? And the second, how many hours you spent in Factorio?
No, I haven't tried any mods. I played vanilla Factorio all the time, and I was thinking, should I like start programming mods? But I think they are like in a weird language, Python.
No, it's in Lua.
Lua. Oh, okay.
Yes, and
it's not that weird language.
It's not weird. It's
not
more. It's much more similar in the Factorio, because I made one or two small mods. Much more similar to the JavaScript stuff. You have a JSON on the input with definitions and very simple operations for the simple mods, of course. The more complicated mods are complicated. Okay.
I don't think I spend a lot of hours playing, but they just go by very fast. So probably I did. But I spent a lot of hours watching other people play. There are YouTube videos that are very funny. People building mega bases, or there's this like death world where they are constantly being attacked by biters and spitters, and it's fun watching that stuff.